Today we're going to talk about free body diagrams and how they're used to show forces acting on an object. Free body diagrams are pictures that show the size and direction of all forces acting on an object. The figure on the right shows 4 different forces acting on an object: normal force, gravitational force, applied force, and frictional force. Make sure that each force is properly labeled. In order to draw a free body diagram, we have to follow 4 steps. First, we have to pick an object to analyze. Second, we have to draw a box to represent that object. Third, you'll draw an arrow for each force acting on the object. And then fourth, each arrow must be drawn in the right direction and has to be the right size for the force. Use a bigger arrow for larger forces and use a shorter arrow for smaller forces. Let's try a few problems. Let's say a book is at rest on top of a table. Which of the following 2 diagrams would show the proper forces acting on that object, A or B? Just click A or B for your answer. If you chose A, we do have gravity acting on the book, but what's keeping the book from falling through the table? Why don't you click the button to review your diagrams and try again. B is correct. We have both a gravitational force pulling the book down and a normal force of the table pushing back up on the book, so that it actually sits there at rest. These forces are balanced, which means they cancel each other out. In this problem, an egg is free falling from a nest from a tree. If we neglect air resistance, which of the following diagrams would represent the forces acting on that object? Would be A or B? Although we have gravity acting on the object, is there a normal force pushing back up on it? Why don't you click the button to review our steps and try again. A is correct. Any object that's in free fall has only one force acting object, and that's gravity pulling it downward. In this problem, we're going to apply a rightward force to the book that's sitting on the table in order to move it across the desk. We're also going to consider frictional forces but neglect air resistance. Which of the 2 following diagrams would represent the forces acting on that book? We do have gravity and the normal force keeping the book on the table, and we did consider friction. What happened to the applied force? Why don't you click the button to review your steps and try again. Notice we have all 4 forces acting on this. We have a gravitational force pulling down and a normal force of the table pushing back up to keep it on the desk. We have an applied force going to the right and a frictional force pushing back. Notice the applied force is larger than the frictional force, which means the book is actually moving. In this problem, a car runs out of gas and coasts to a stop on flat ground. Which free body diagram would represent the force acting on the car, A or B? Gravity and normal forces are still there, and we do have friction slowing down the car, but what applied force is keeping the car going forward? Why don't you click the button to review your steps and try again. Even though the car is coasting down the hill, or close on the flat ground, it's just dragging. We have friction slowing the car. There is no more applied force moving the car forward, only friction slowing it down. So this is the correct answer. Free body diagrams are a great way to represent all the forces acting on an object, and they're also very useful to understand how we can calculate the forces. So, why don't you click the button below to get more practice on drawing free body diagrams, and we'll work on calculations later.